First off, I would just like to say I'm very excited to present my research, and I've been learning a lot from the rest of your presentations, and I'm also looking forward to the rest of the presentations today. So my mentor's name was Shelby Vexler, and she's a graduate student at UCLA. And the topic of my paper was an evaluation of the preservative systems in personal care products. So introduction to the preservative system. So if you have ever looked on the back of like a product, for example, a shampoo, you have probably seen lots of chemicals, and you might have thought that all those chemicals have some sort of use for their purpose. Like, in other words, like all the chemicals should just be to clean your hair, right? No, all of chemicals work in different ways, and one of the ways is preservation. So throughout civilization, humans have used various methods to preserve food and other kinds of products. So in the past, when refrigeration did not exist, humans used salt on meat in order to preserve meat, and also for fruits, like you have dried fruits, because in the past humans could not refrigerate their fruit and like conserve the juices inside the fruit. So they dried out fruits in order to be able to eat fruits throughout the whole year. So for products like shampoos and toothpaste, you don't refrigerate toothpaste and shampoos. So they have something called synthetic preservatives. So they are important because they preserve the quality of the product. They make sure that the product continues to work throughout various periods of time, and they are also essential in order to inhibit bacterial growth. So every day, humans are exposed to different kinds of bacteria, and when you're using products like shampoo or like a bar of soap, you're continuously touching it and you're exposing it to bacteria. So preservatives have to be included in the products in order for them to not grow bacteria and you to be exposed to bacterial growths. So preservatives that prevent bacterial growths, infections such as P. aeruginosa, Pseudomonas, Aspergillus, etc. And so personal care products are regulated as cosmetic products under the law. And so the Food, Drug, and Cosmetic Act in 1938 was essential to regulate preservatives and personal care products as well as cosmetics. And it was extended with the Pure Food and Drug Act of the dates are kind of mixed up, but it was introduced in 1906 and then extended in 1938 in order to regulate cosmetics and then personal cosmetics. And so the Cosmetic Ingredient Review Board assesses the safety of numerous preservatives for cosmetics. And so even though there are various agencies, federal and outside agencies regulating preservatives and the chemicals found in personal care products and other cosmetics, there has been some skepticism of the safety of synthetic preservatives, because especially in 2004, there was a study that claimed that preservatives such as parabens have a significant impact on advancing cancer in humans and introducing cancer in humans. That was later found to be false, but because of studies such as those, it has created some controversies and hysteria, and people kind of avoid preservatives or synthetic preservatives and look towards more natural kinds of preservatives. So the purpose of this paper was to evaluate the effectiveness as well as the safety of the various preservative systems in personal care products. And also, it is important to evaluate the safety and the effectiveness of personal care, the preservative systems and personal care items, because throughout the late 20th century, various sanitation epidemics have occurred, and this has occurred because of the high concentrations of preservatives found in various personal care items. And so sanitation is basically when you develop like different skin allergies like eczema because of these chemicals called preservatives found in the products you use on your skin. So it has been increasingly important to look and evaluate the various chemicals found in products. So my research was composed of both a literature review and experimental data. So for the experimental portion, I had my materials and methods section. So I found 10 different personal care items in my home, including various shampoos, which are listed on the table right here, and other kinds of shower gels, clay masks, baby powder, and soaps. And so my mentor sent me agar plates, which are just plates with just like agar on them. And so agar was used because they provide a source of nutrients for bacteria, so I could evaluate the effectiveness of the various preservative systems. So what I did was applied an even layer of the 10 products on the plates, and I left it in a warm indoor environment in order to expose them to any microorganisms present in the environment. And then each plate was photographed daily for over 10 days to monitor bacterial growths. And the presence of growth was determined by eye. And this program called ImageJ was utilized to measure the total area of growth. And so after I conducted my initial experiment, I will talk more about this later, but I conducted a second follow-up experiment, and it was the second follow-up experiment was conducted with the same method as the first experiment, but I just had to swap the growths from the initial experiment and swap it onto the second plates for the second experiment. And so I only did the second follow-up experiment with the one open control plate, one castor oil plate, and one cleanser plate because I had to verify the certainty of the growths from those plates from the initial experiment. So for my experimental results, I initially used 10 different products in the agar petri dishes, and I found after 10 days that only 5 products out of 10 exhibited some sort of bacterial growth, and the products that were unable to prevent growths were baby powder, castor oil, cleanser, lotion, and soft soap. So these were the products that had some kind of growth. But yeah, and here I have a figure of the growths that I did find in the 5 different products. And for the open control plates and the closed control plates, I did find that they did exhibit some kinds of growth too. And there were some like errors, I believe, because for the baby powder, since I did 3 trials for each product, for the baby powder, only 1 trial exhibited some kind of growth, and it was only 1 distinguishable growth in that 1 plate. So there were some like inconsistencies. And so also in the open control castor oil and cleanser plates, there were also some kinds of inconsistencies because in the open control plate, while I did identify growths in the initial experiment, they were kind of opaque and difficult to identify without looking very, very closely. And with the castor oil, 1 trial did not exhibit as much growth as the other trials did, and it kind of looked like dried pieces of agar instead of kind of growth. So I wanted to make sure that the growths that I did find in the initial experiment were actually growths. So for the second experiment, for the open control castor oil and cleanser plates, I swapped the growths from the initial plates and replated them in new plates. And I waited 4 days to see if there were any kinds of growths, and I did find some growths. And yeah, so there were 22 growths in the cleanser plate, 8 growths in the castor oil plate, and thousands of microscopic growths in the open control plate. So I have a picture here. So growths are presented in control open trial 2 for this first plate, the second plate is the castor oil trial, 1 plate, and the cleanser trial, 1 plate. And yeah, so this one has thousands of microscopic growths, but it's kind of hard to see in a picture. And yeah, so all of these had growths. And you can see more clearly with the cleanser petri dish, the growths. So the second part of my paper focused on the literature results I found from my literature review of various different research papers. So for my literature review, I found that preservative systems must adhere to clean and thorough manufacturing methods, be composed of clean and safe materials, and be verified through various challenge tests in which a product's ability to destroy bacteria is tested with a specific amount of organisms like gram-positive bacteria, gram-negative bacteria, and yeast. And I also found that pH is very important in products. So a pH of less than or greater than 10 is hostile to bacteria and cosmetics. So those pH ranges are ideal for resisting bacterial growth in cosmetics and other personal care items. So if the pH is between 4 and 10, it's not ideal, and most likely there will be some kind of bacterial growth. And so the packaging system for the product also affects the microbial resistance of the product. And so there are certain kinds of packaging that are more effective against bacteria than others. So like pipe systems with pumps and disposable containers are very effective at preventing bacterial growth. However, containers with screw caps are not. And so the best preservative system should keep the product safe against a wide spectrum of bacterial growth while the product is sealed in its packaging and throughout consumers' use, as the products are very likely exposed to bacteria throughout these periods of time. So in order to meet all those kinds of criteria, manufacturers combine a variety of preservatives in order to create the most effective chemical system, reducing the necessity of active preservatives and amplifying the biocidical abilities. So because so many different kinds of preservatives are used, manufacturers are able to reduce the instances of sinistation. So with less concentrations of preservatives in a product of a certain, like if there is less of a concentration of a specific preservative, there's less of a chance that humans will just develop some sort of skin allergy or eczema to because of the product. So some of the most popular preservatives in cosmetics fall into the following categories, which are organic acids, alcohols, and phenols, aldehydes, and formaldehyde releasers, isothiophylizins, bigonides, quaternary ammonium compounds, nitrogen compounds, heavy metal derivatives, and inorganic compounds. And so usually these kinds of preservatives are not used by themselves because there is greater benefit using them in combinations, especially because in combination they prevent skin allergies and are more effective. So popular combinations of preservatives include alcohols with their salt, which successfully hinders protein functions, and another popular combination includes phenoxyethanol, benzoic acid, and sorbic acid, with sometimes other preservatives. So from the initial experiment, which I waited throughout the course of 10 days, I found that the results imply a lack of effective preservation against microbes commonly found in cosmetic products, which include Pseudomonas aeruginosa, Klebsiella oxytoca, and more. And the growths present in the cleanser, lotion, and soft soap were especially a singular obscure shape outlining the agar plate, which almost looked like dried out pieces of agar. So It is possible that as the agar dried, the sides of the agar lacking any product were exposed, permitting growth in this location. So those are some of the inconsistencies with the initial experiment. And then with the first initial experiment, the castor oil plates exhibited the most area of growth out of all the products. But this also seems like an inconsistency because the Garner et al. Study described that all oil-based products do not need preservatives as they do not contain water, as mostly products with water require preservatives while oil-based products don't. So the castor oil used in this experiment was 100% pure oil. However, applying it to the nutrient-dense agar may have compromised its abilities as an antimicrobial because the second experiment did verify that the initial experiments growths in the castor oil plates were actual growths. So this suggests that oil-based products without preservatives present may also exhibit bacterial growth. So currently, products based on oil-based products may not actually be effective at preventing bacterial growth, so they may also require preservatives. And so there were 5 other products that did not exhibit any kind of growth, but I found that there might have also been inconsistencies because these products usually dried up quickly, and because they dried up quickly throughout the course of 10 days, there weren't much differences in their images, and I could not find any kinds of bacterial growth. So it is not certain that these products have an effective preservative system despite the lack of bacteria in these plates. So products without preservatives are usually poor at resisting microbial growth, and but through this experiment, I found that packaging may be an effective tool to prevent bacterial growth. Though preservatives are necessary for products, when I compared the open control plates and the closed control plates, the closed control plates definitely had less growths than the open control plates, showing that packaging is very important in preventing growths. And in regards to the 5 products that did exhibit growths and the 5 products that did not exhibit any kind of growths, the products that did not exhibit any kinds of growth contained isothiozoleins and phenols, which the products that did exhibit growths did not include. So it may imply that these chemicals prevented growth more effectively than the preservative chemicals found in the products that did exhibit growth, but this might not translate to real-world applications, and consumers may be skeptical of this because again, I was part of the online chapter, so I had to do these experiments at home, so the environment was not very sterile, and if I were able to redo this experiment in a sterile lab, the results would be much more accurate. So the preservatives available in the personal care products, that I used for this experiment are currently deemed safe by the FDA, but as controversial studies have continued to be published and fear of preservatives have grown, future studies may look towards the efficacy and certainty of products labeled as preservative-free. So studies have currently been looking towards like natural preservatives, so not using these synthetic preservatives at all, which is not an effective way to prevent bacterial growth, and which is obviously very dangerous to consumers because they might be exposed to bacteria when using these products. So a lot of companies and researchers have recently labeled their products as preservative free because under the FDA, there are only certain chemical classes labeled as preservatives. So companies may label chemicals that work in a function similar to preservatives as not preservatives because they aren't labeled in the FDA regulations as preservatives. So there are lots of controversies with that. And so, and one more point is with parabens, though, like I mentioned parabens in the intro that they have been a topic of controversy because studies have exhibited that they may cause cancer. However, those studies have been proven to be false by various researchers and scientists. But there is a growing hysteria in communities, especially in natural communities that promote like natural products and natural chemicals. So there may be a future of products without preservatives, but it is still a field that it needs more research in because obviously these chemicals are deemed safe by the FDA and they are very important in preventing hospitalizations. So I wanted to say thank you to my mentor, Ms. Shelby Vexler, who introduced me to this topic and allowed me to do research, experimental research at home by sending agar plates through the mail. And I was able to learn a lot about this field, and I feel like this field is not something that's done a lot of research on, because definitely when I was doing my own literature review and reading research studies, there were limited amounts of studies. So I feel really grateful to do research on a topic that has not been looked very closely at. So also thank you for everyone to listening to my presentation.